What if the shield around our solar system, the heliosphere, isn't a comet-shaped bubble, but actually looks like a baked croissant? Imagine, if you will, floating in the silent velvet blackness of interstellar space. All around you, the galaxy glitters with the light of 100 billion suns. It's a place of profound beauty, but also of immense danger. Unseen energies, particles accelerated to nearly the speed of light by distant supernovae, crisscross the void. They are the cosmic rays, a form of radiation so powerful it can shred the very fabric of life. Yet, here we are. On a small blue world, life has flourished for billions of years, largely untouched by this cosmic storm. How is this possible? What invisible shield protects our tiny corner of the universe, and what shape does it take as it plows through the galaxy? So what exactly is this bubble? It's called the heliosphere. Helios, ancient Greek for sun, sphere, a ball or bubble. Simple terms, a colossal magnetic bubble, inflated by a stream of particles from the sun. This stream is the solar wind. Our star isn't just sitting there shining, it's actively breathing, exhaling a torrent of charged particles, protons, electrons. The wind travels at incredible speeds, over 1 million miles per hour, carrying the sun's magnetic field outward past the planets. For a long time, the scientific consensus on the shape of the heliosphere was based on a simple, intuitive idea. We are moving. The entire solar system is hurtling through the interstellar medium at about 50,000 miles per hour. Just as a speedboat creates a wake as it cuts through water, we assumed our heliosphere would create a similar structure as it moved through the galactic gas. The prevailing model, therefore, was that of a comet. It was a beautiful and elegant picture that made perfect sense. It was the image you would see in countless textbooks and science documentaries for decades. This comet model described the heliosphere as having a rounded, blunt nose in the direction of its motion, the bow shock. The breakthrough in our understanding came from a rather unassuming NASA spacecraft. It was called the Interstellar Boundary Explorer, or IBEX. Launched in 2008, IBEX had a unique and ingenious mission. Instead of traveling to the edge of the solar system like the Voyager probes, it stayed in orbit around Earth. Its job was not to taste the interstellar medium directly, but to create a map of the entire heliospheric boundary from afar. It did this by detecting particles that are born at that distant frontier and travel all the way back toward the sun. After years of collecting data from IBEX, and combining it with measurements from the Voyager probes and some pretty sophisticated new computer simulations, the new picture finally emerged. And it was honestly astonishing. The heliosphere does not look like a comet. Instead, the best analogy for its shape is a croissant. Side by side, old comet model versus croissant model. Two giant puffy jets curling back from a central rounded nose like the lobes of a freshly baked pastry. The long, defined tail that was the hallmark of the old model just isn't there. The bubble is far more compact and, well, strangely symmetrical than we ever thought possible. So what is the secret ingredient that helps to inflate the heliosphere into this puffy croissant shape, resisting the formation of a long tail? The answer, it turns out, lies with a special class of particles known as pickup ions. These particles weren't really a major component of the old models, but the new research shows they're actually the key sculptors of our heliosphere's shape. You could say they're, in essence, the yeast that makes the croissant rise. Understanding them is really central to figuring out why our bubble looks the way it does. Pickup ions are born when neutral atoms from interstellar space drift into our solar system. The most common of these is neutral hydrogen. As these atoms get closer to the sun, they're bombarded by solar ultraviolet light, which can knock an electron off them, giving them a positive charge. Once they have a charge, they're picked up by the sun's magnetic field and swept along with the solar wind. They start off cold and slow, but eventually they get carried outwards at supersonic speeds, becoming an integral part of the solar wind. Crucially, these pickup ions are much hotter than the original particles of the solar wind. This new croissant-shaped model of the heliosphere isn't just a curiosity for astrophysicists. It actually has real-world implications for life on Earth. The shape and size of our shield directly determine how effectively it protects us from galactic cosmic rays. These high-energy particles are a constant threat. They can damage DNA, they can increase cancer risks. They pose a significant danger to astronauts on long-duration missions beyond Earth's magnetic field. The old comet model, long, unstable tail, suggested an easier pathway into the solar system from the rear. It was imagined as a potential weak spot in our defenses. The new Croissant model changes that calculation entirely. It's more compact and lacks an extended tail, so the entry paths for cosmic rays are different. Our sun is not unique, it's just one of billions of stars in the Milky Way galaxy, and we now know that most of those stars have planets. This raises one of the most profound questions we can ask. Are we alone? As we search for habitable worlds beyond our own, we're not just looking for rocky planets in the so-called Goldilocks zone where liquid water can exist. We also have to look for planets that are adequately protected from the harsh radiation of space. The discovery of our heliosphere's true shape gives us a brand new tool in this search. The presence of a robust astrosphere, a star's version of a heliosphere, may be a critical prerequisite for a planet to develop and sustain life. A star that produces a weak stellar wind, or one that lives in a particularly harsh region of the galaxy, might not be able to create a bubble strong enough to fend off cosmic rays. This journey to the edge of our solar system and back has left us with a beautiful and humbling new image of our home. We are travelers inside a strange, croissant-shaped bubble sculpted by invisible forces as we move through the galaxy. This discovery is more than a scientific update, it's a moment that invites us to look up and feel wonder. It reminds us there are profound mysteries in our cosmic backyard. We live on a protected planet. By understanding its present shape, we can better model its past and future, and its role in the long, epic story of life on our planet. And that surely is a magnificent thing.